Hello again. Here is Rahul from Tvarit, Fabian from Beckhoff. We are here again with this series Industrial AI, and this is video number 2. This video 2 will explain how to implement industrial AI projects successfully in real life environment on the shop floor. Be it quality initiative, energy, maintenance initiative, what are those special ingredients in order to get started? We will definitely keep it as interactive as we have done in video number 1. Let's get started.
Rahul, can you explain to us a little bit these milestones here given on the slide?
Definitely. Why is it important? I think we have to definitely understand this. I mean, it's so important. This is at the end of the day an AI recipe. And I think every one of us are aware a recipe in your kitchen. If there is something wrong in the recipe, it requires certain ingredient, salt, chili, pepper. In Indian kitchen, the number of ingredients are probably more than 30, more than 50. The same concept applies here. If your ingredients of the AI are not good, your AI will not function. Let us understand what are those ingredients. Okay, so this first very important thing is to be aware about the data. Data awareness is very, very important ingredient. The second one is being hardware ready. If we are not hardware ready, we cannot collect the data. Without data, sorry, no analytics, no AI, no benefits. Data readiness, data driven. Data driven is also very, very important philosophy. Once we have data, let us start utilizing them for calculation of the important KPIs. As I talked earlier, these important KPIs can be from energy perspective, from defect perspective, and also from MTTR, MTBF perspective for predictive maintenance use cases. Once we have these 4 steps, then only we will become AI ready. And finally, we will be able to utilize Tvarit industrial AI software. And this software definitely can give you the benefits. Let's go back, take a reverse journey. What are these 4 steps? Fabian, please.
Yeah, so what are the functions or the products where Beckhoff can help you in those milestones? Hardware ready. So that's simple. PC-based control is a key concept in being hardware ready for AI processes, because the PC-based control offers you the opportunity to combine your automation technology or operation technology with the information technology. So it's all the same device. We provide you the interfaces to bring all your data from the shop floor to the upper hierarchy layers. That's the basic concept of PC-based control, using the synergies between information technology and automation or operation technology. Data ready. So we also, of course, offer you the toolings, the flexible products to somehow get the data out of your controllers. So, for example, the database server, already years in the field and still being used in many, many applications, that connects you directly from the PLC to a database of your choice, for example, Progress or MySQL or MS SQL, doesn't matter. You choose your database, and we offer the interface using the database server. And then you stream directly from the PLC into an SQL or even a NoSQL database. Analytics Logger, a quite new product, is also able to basically realize something like a flight recorder of your PLC. So it's meant to be right now the most performant data logger that we have. So you instantiate your analytics logger, you select by just clicking in the engineering system what variables do you want to have logged. You select the target where it has to be logged, and that's it. Or the oldest software product in the field here, the TwinCAT scope. TwinCAT scope, we already had this in TwinCAT 2. It's now the TwinCAT 3 scope, and it's equipped with lots of different possibilities to record data, to store data in different file formats. Data-driven. So, of course, we also provide you with the tools for first exploring your data. Like we have the condition monitoring toolbox for doing in the PLC feature engineering, if you like. We provide you tools like TwinCAT Analytics to basically engineer your signal analysis chains not in the PLC language, but in the graphical interface. And of course, we have the inbuilt machine learning inference engine that also allows you to directly compute your machine learning algorithms, maybe also some pre processing steps like a PCA directly in the PLC. And then we end up at the very end at step 5 with AI ready and Tvarit industrial AI.
So, kitchen is ready. We have all the ingredients. We have bought everything what is needed in order to make a very tasty recipe. Yeah. Now, what is the second step? The second step is to choose what exactly do we have to make. In other terms, if I say, what kind of use case shall we start, which is going to be the most tasty use case, I would say. It's very important to select this particular use case also for the senior management, because at the end of the day, they want to see, they want to feel it, they want to test it. How good is it in order to expand? What here I am showing is a use case selection framework. For a typical die casting industry, this is one of the example, but eventually this can also be applicable for your industry. Here on the top, I have written melting, which is process step number 1. Casting is process step number 2. Then heat treatment, machining, and finally, an automotive component gets painted. Once it is painted, the recipe is ready. It can be distributed. Now, on this side, I have explained the kind of use cases: prescriptive quality, maintenance, energy initiative, and then finally production planning initiatives. These are more or less the 4 biggest areas where industrial AI can help very much. Here, how do we select these use cases? From Tvarit side, we provide services in order to do the estimation of ROI. We have these ROI frameworks ready, and on the basis of that, we take decisions. For instance, in melting area, energy is the most important KPI, and hence you can see here is the red dot. And similarly, those other use cases are also identified, they are prioritized, and then they are ranked. The number 1 use case or number 2, number 3 is selected in collaboration with customer users. And once this is selected, let us understand now step number 3. Perfect. So step number 3. Step number 3 is user onboarding. Why is this user onboarding important? I think there is little bit also a myth in the market that AI can work all alone, completely in an automated manner. I think probably some of the consumer AI does that, but unfortunately here in this case of industrial AI, it's not the case. In case of industrial AI, it's very important to onboard the user. Also, it's very important for users to understand. It's also very important to train them so that at each step of our industrial AI implementation journey, we are together. For this, we have framework for assessment, preparing a plan, preparing industrial AI journey, finally the planning of it, implementation, and once industrial AI has implemented, finally, how do you sustain those results? And once you do all these steps, and once the users do all these steps, then only success is assured. And then only this recipe will taste wonderful. Yeah. So this is the overall concept, and we make sure that users are very well trained for all of these steps, and they take huge interest in implementing this journey. Perfect. Okay, so for the step number 4, I would say once we have the AI readiness, which is your getting your kitchen ready. Number 2 was selecting a specific recipe, a use case. Number 3, getting users ready, onboarding them. Now let us start with data science project. This comes in step number 4. So please, without doing those 3 steps, please do not start directly with the data science. Data science is a technology, industrial AI implementation is a technology, but those 3 steps are very important from organizational point of view. Perfect. So let us understand this data science life cycle. This is a pretty known DM crisp methodology. In this methodology, step number 1 of a data science project start always from data collection, business understanding, and data understanding. This is more like a loop. Here, Fabian also will bring his expertise to explain how can we implement those 3 steps. Further, once we have the data, the 4th step is data preparation, AI modeling. Evaluation is also very important. How good is this recipe? We have to test this, otherwise we can't really implement, we can't really deploy. And then finally comes the deployment. Let us understand from Fabian the initial 3 steps.
Well, so of course, first of all, the business understanding has to be the key driver of the complete project. And that's why we also have the domain expert at the very right here, together with the TwinCAT specialist and also with the data scientist. So only all those players together, maybe also the data engineer, if this is a distinctive role, they all work together in this project. So the domain experts provides the business understanding. They know what they want to achieve. The TwinCAT expert can help with the data collection. So the TwinCAT expert knows how to get the data, how to bring in meta information, how to store the data, and also how the data needs to be how to understand this data. So and it's in deep interaction always with the domain expert. The domain expert knows the process. The TwinCAT expert has the know-how of the real implementation, maybe on the PLC. And together they can work on the data understanding. And of course, this is a loop. So without understanding the data and in contrast to the business understanding, this doesn't work. Only if you have a fruitful data that relates to your business concept, then it makes sense to hand over to the data scientist, who will then continue with the modeling. And Rahul will explain then the next few steps.
Great, perfect. So here the data preparation is very important in order to make the data in a correct format. The format, if the format is not important, unfortunately, the machine learning, deep learning, neural network related algorithms, they will not understand what is this data. Yeah, so you have to form your input parameter space as well as your output parameter space in a certain format. Then, of course, these neural network deep learning algorithms will work. And finally comes the evaluation. We will also talk about these things in detail now in the coming slides.
And of course, the final step is then to deploy your learned algorithm somewhere in the factory floor. And of course, the deployment step is very crucial. So, and there are many different requirements, maybe in terms of deterministic behavior, latency, or compute power. And we will see in the next few minutes what kind of products and support we can add to your AI project as Beckhoff. So maybe let's start with data collection. Let's have a quick look into what is relevant. So mostly it's basically you start with I want to have data, but then you need to ask questions like what kind of data, what is the infrastructure, also from IT perspective, and what are what is the data? Data is only a value like 24 or 57. If you bring this data to a data scientist, say I have collected lots of data, so a table of 1 million variables, and there is something like, hey, here is 42 and here is 75. This will not help. The data scientist will always need to have meta information. So basically, the data has the requirements to hold meta information, maybe the unit, and also other meta information, maybe on the production step or whatever is relevant to understand this value. The data has to be structured, and of course, it has to be computer readable. So don't work with with data formats that nobody understands, because otherwise the data scientist will go mad and work hours on just getting the data into his framework. And Beckhoff provides you lots of different products to realize this data logging. So we already introduced a few of them, like TwinCAT Scope, Analytics Logger, and Database Server. And on top here, we also have the data agent or TwinCAT IoT products that realize a communication interface to the IoT hierarchy layers. So what is the difference between all those products? Differences are, for example, you can choose a data format. We also, for example, we have TwinCAT Scope, which can log in, for example, CSV files or in TDMS files. We have the Analytics Logger, which is able to, first of all, log in a binary format, but then offers you the possibility to convert again to computer-readable and standard file formats. We have the Database Server with a standard connectivity to standard SQL and NoSQL databases. We have the TwinCAT IoT products here with the data agent, which enables you to communicate standard JSON packages over MQTT to a message broker, which can then forward the message to your database of choice. What is also the difference, not only the data format, but also the communication way. For example, if you use the data agent, you can speak MQTT or AMQP. It really matters on the IT infrastructure of the end customer. What kind of ports are open, for example? Do you have the allowance to use MQTT or AMQP ports? Or are you only allowed to use OPC UA? That is one aspect in communication. On the other hand, are you allowed to store your data locally somewhere on a disk, for example? Or is there an SQL server available in the network? Or is there a private or even a public cloud available in the network? And depending on all those different requirements that may occur in a production environment, we can always choose the right product out of the shelf and use standard products for all those use cases.
Perfect. So we have data. What do we do next? Okay, so as I explained earlier, we need to bring this data in a correct format. Traceability is very important in order to make the format of the data very correct. Traceability is a very important concept in the industrial AI implementation. Traceability, in simpler terms, is essentially to trace a specific automotive component object under a manufacturing process. How do we trace it? And then corresponding to that particular component, how do we format the input process parameter space, input data? In this example, we are showing the raw material as the starting point, warehouse. From warehouse, the material goes in the manufacturing process. Finally, after manufacturing process, the finalized product gets out. Quality is happening, and then finally finished product is distributed. And in this process, traceability is important. From Beckhoff side, we have some traceability products. Let us hear.
Well, of course, it always depends on the real application, on the requirements, what kind of product can be chosen. But for example, if it comes to the warehouse, for example, basically the concept of our open automation infrastructure is very important. For example, if you have the ability to use a QR code reader which implements an OPC interface, then of course you can directly speak with your PLC. So I've chosen this product out of the shelf, and now I'm placing this in the production line. If you use, for example, our extended transport system or the explainer system to transport your products through the production line, you always have maximum of traceability, because you don't leave your product alone on a conveyor, but you hold it all the time and you know exactly where it is. So you have full flexibility and full traceability during the complete process through the machine. And of course, in the end, quality assessment We have lots of different products. One example might be for TwinCAT Vision for vision-based quality inspection at the end of the line.
Perfect. Okay, what next? So here we have data in correct format. What next? Once the data is in correct format, we start putting this data into our AI algorithms. Our AI algorithms essentially takes in a very simple manner these data as input, and they train the neural networks if it is a deep learning algorithm, or if it is a machine learning, then those algorithms. This is pretty clear concept nowadays for everyone. Very easy to understand. You have the input process parameter space and you have your output, and we can simply train AI algorithm. Now, apart from this, apart from the data-driven methodology, there is still one last piece of the puzzle which is missing. What is that? I think probably most of you can guess already. For an industrial AI project, domain expertise is very, very important. And precisely that's what I am talking here about. The last fourth piece in this case is physics and chemistry based knowledge. How do we imbibe the physics process or chemistry based process knowledge into our AI? That's where Tvarit has invented a new algorithm which is hybrid AI, hybrid industrial AI. And this hybrid model approach not only takes the input data from material process quality, but also it takes the data, input data from finite element modeling. And finite element analysis essentially gives us the defect simulations, the simulated data. And once you combine the simulated data with your real-time process data, results are going to be amazing. Perfect. And this is just a very brief glimpse about our software, the Tvarit Industrial AI Framework. How does it look like? In our Tvarit Industrial AI Framework, we have first these three steps: machines, parameter, and jobs. Machines, there we can define a specific type of machine. We already have a repository of machine for metal industry, but eventually for others as well, we can create this repository. Next step is, for that particular machine, what are the important parameters? Temperature, pressure, torque, airflow, etc. All of them can be set in the phase number 2. Then comes the jobs. Here in the jobs, you can actually choose specific type of data science step which you want to run on the data. And the results are also shown in a very easy to understand manner. Here you can click on the button output. Output will show you the end result of the algorithm. Okay, good. So now we have talked really about how to run this industrial AI software. Once we have the results available with us, the next logical step is to do testing, to do evaluation. In case of classification, usually the evaluation metrics, as I have shown in one of the example, is done on the basis of false positive, false negative, true positive, true negative. The most important here is to optimize the number of total false positive and total number of false negatives. Once we are able to optimize, in some of the industrial AI application, people want less number of false negatives, whereas on other hand, in some other industrial applications, they are afraid of false alarms, false positives. So it really depends on the end application. Okay, and finally, these results can be shown on a very easy to understand dashboards. Users, machine operator, shift supervisors, the foundry managers or the machining area managers, they can actually see these results, and then they can eventually optimize these false positive, false negative. They can give their wishes to our team. Our team eventually can change the backend, and at the end of the day, once everything is super accurate and fantastic, then finally the model can be deployed. Let us understand how deployment work.
Thank you, Rahul, for this nice introduction to your software framework. So, of course, in the end, you want to have your algorithm deployed somewhere in the factory floor. So, because we use PC-based control, we always have processing power. So we can scale the CPU from, for example, the small Intel Atom and up to the Intel Xeon processor. It doesn't matter if you use it if you use the Intel Atom as a controller with PLC logic and, for example, use our Xeon-based server as an edge device, or you directly use the Intel Xeon-based server as a controller. Both is possible, and this is part of the flexibility of what Beckhoff offers. We provide you the processing power to run the AI models directly where the process happens, where the data is generated, which is very close to the PLC. For this, we have also two different products available. So one is deploy your learned algorithm directly inside of the PLC, inside of the controller, and run it in hard real time. The other product is deploy it at edge in the user mode with the ability to also access hardware accelerators. Then we provide you a PLC interface, and you can, as a PLC programmer, still use standard PLC logic, PLC function blocks inside of our TwinCAT machine learning library that you can instantiate and work with. And so we have a high performance interface then between TwinCAT and the inference engine. Either the inference engine directly runs inside of TwinCAT in hard real time, or near the process and with maybe access to GPUs or other hardware accelerators like FPGAs in the user mode. The third possibility, of course, is to use cloud deployment. If you don't need to have a reaction back to the machine, of course, cloud deployment is a good opportunity to run your AI also. So you just communicate from the factory floor to the cloud, run your AI algorithm, and, for example, show the result on a dashboard. If you don't need to have a reaction back, that's in most cases totally fine. So thank you very much for watching this video. If you want to contact us and need additional information or just want to speak about your AI initiative, please contact us under beckhoff.ai or tvarit.com.
Thank you from my side as well. Thank you very much for being here. And yeah, as you know, tvarit.com, we have this website available, and we will be able to we will be happy to support you in successful implementation. Thank you.